Let us now solve some previous year questions on HCF and LCM. So these are basically from Achiever section. So each of them will carry 2 marks each. The first question, we have to match the answers for the given options that we have. The number of factors of 125. So we'll start solving each of them, and then later we'll see if there is any pattern that will help us to solve this quickly. The number of factors of 125 is. So in order to find factors of any number, we need to build the factor pairs first, right? So if I have 125, so the factor pairs can be 1 times 25. 2, it is not divisible. 1 times 125. It is not divisible by 2, it is not divisible by 3, so we'll have 5. So 5 times 25 is 125, right? And then if we check for any further numbers, it will not be divisible by them. So the number of factors of 125 will be 1, 2, 3, 4, right? So 1, 5, 25 and 125 are the only factors of 125. So the answer for this is 4. Common prime factor of 15 and 50. So we have to find a prime factor that is common for 15 and 50. So whenever we are given that we need to find the prime factor or even common prime factor, we need to do prime factorization. And to do prime factorization, we need to build factor trees. Okay, so I'll just write 15, so 3, and then 5. So this is the prime factorization. So we can write 15 as 3 times 5. Okay, then we have 50. So we'll do 2 times 25, and then this is a prime number, so we'll not build the tree further, and this will give us 5 times 5. Right, so 50 will be 2 times 5 times 5. So if you look at the prime factor, so that is common among both of these numbers, so it will be 5. Then the LCM of 16 and 34 is. Again, when we are required to find the LCM, there can be 2 ways. One is to list down the multiples of both the numbers and then find the common multiples and then find the least common multiple. Other ways to find the factor tree. The listing method we can use if we get a number for which we are easily able to remember the tables, say from 1 to 20. So if the numbers are less than 20, if both the numbers are less than 20, we can use the listing method. If they are greater than 20, so we should be using the prime factorization or the factor tree method. Okay, so 16, if I have to write the factor tree, again in exam you don't have to construct the entire thing, you can just write it like this. So 16, then we'll write 2 times 8, and then 8 will write 2 times 4, and then 4 will write 2 times 2. Right, so 16 will be 2 times 2 times 2 times 2. So this is the prime factorization of 16 is 2 times 2 times 2 times 2. Right, and then for 34, if we have to do, we'll divide this with 2, we'll get 17. 17 is a prime number, 2 is a prime number as well. So 17, we'll write this as 34. We can write 34 as 2 times 17. Right, now we identify the common term, which is 2. So the LCM will be 2 times 2 times 2 times 2 times 17. Okay. So 2 to the 4, 4 to the 8, 8 to the 16, 16 times 17. So out of the option 272, we can quickly multiply and check. So 17 and then 16. Right, so 7 6 are 42, carries 4. 6 1 is 6, plus 4 is 10, and then here we'll have 17. So 2 will come down, 7, 2. So 272. So the LCM is 272. And then the HCF of 98 and 14. Right, so the HCF of 98 and 14, again, they are larger than 20. So we'll use the factor tree method. So 14, if I have to write, we'll get 2 and 7. And 98, if I'll write, I'll get 2 times 49 and then 7 times 7. Right, so 14 will be 2 times 7 and 98 will be 2 times 7 times 7. Right, so what is common? 2 and 7. So that will be the HCF. So HCF is 2 times 7, which is equal to 14. Now see, to solve this question, we took some time, right? However, in exam, we won't be given so much time. So how do we identify which is the correct option very quickly? This one we can solve quickly. This one we can solve quickly. These two will take some time. What we can do is, see, when we are computing the LCM of two numbers, right? So the LCM of two numbers must be greater than both the numbers. It can be greater than or equal to both the numbers. So it can never be less than both the numbers. So for example, the HCF of 16 and 34 can never be less than 34. Okay, and the HCF of 16 and 34 can never be greater than 16. Right, so think of it like this: multiple of a number is always greater than or equal to that number, and factor of that number is always less than or equal to that number. So if we apply that logic here, LCM of 16 and 34, right? So it must be greater than both the numbers. So out of these options, we already got this as the answer. We already got this as the answer. We are only left with 272 and 14. If we check 14, 14 is less than 16. So it cannot be the LCM of this. So without even solving, we know that this must be 272. Okay, this is one trick. The other trick is HCF of 98 and 14. Now, whenever you are given to find the LCM or HCF of two numbers, you quickly check if that number is divisible by the other number, if the larger number is divisible by the smaller number or not. You know 14 times 7 is 98, right? So when the larger number is divisible by the smaller number, then the larger number is the LCM. Again, LCM is always larger. So larger number is the LCM and the smaller number is the HCF. We don't have to calculate. So if these are divisible, if the numbers are divisible by each other, so if the larger number is divisible by the smaller number, we know that this must be the LCM and this must be the HCF. So as you can see, we have calculated the HCF, we got around 14. If we compute LCM, LCM will get 2 times 7, 2 times 7 times 7, right? Because these two are common and then I will write an additional 7. So 2 sevens are 14, 14 sevens are 98. So the LCM is 98, which I already mentioned. So if this is divisible by this is the LCM. LCM is always larger and the smaller is the HCF. Factors are smaller, multiples are larger. Remember this. Okay. Now we move on to the next question. Read the given statements carefully and state T for true and F for false. Right. Again, if you notice something, you have a pattern in the option. Right. So this T, everything is true. So we don't have to solve number 2. Okay, so from here we can see that we do not have to solve this particular option. Otherwise, if you don't look at the option first, we would have solved for this as well. Okay, then we start solving this thing. Sum of LCM of 120 and 72 and HCF of 56 and 72 is 368. So we will first compute the HCF of LCM of 120 and 72. Okay, so if I write 120, okay, again I'll not draw the boxes. If I write 120, so I'll get 2 and then 60, 2 and then 30, 2 and 15, and then 3 and 5. Right, so 120 will be equal to 2 times 2 times 2 times 3 times 5. Okay, and then I have to compute the LCM, the prime factorization, or build the factor tree for 72. So 72 will be 2 times 36, and then 2 times 18, 2 times 9, and then 3 times 3. Right, so 72 if I write, this will be equal to 3 times 2 and 2 times 3. Right, so 3 times 2 and 2 times 3. So this is common, this is also common, this is also common, and this is also common. Right, so the LCM will be 2 times 2 times 2 times 3 times 5 times 3. So LCM is 2 times 2 times 2 times 3 times 5 times 3. Right, so 2 twos are 4, 4 twos are 8, 8 threes are 24, 24 fives are 120, 123s are 360. So it is 360. Now we need to find the HCF of 56 and 72. We have already done the prime factorization of 72, so no need to repeat it. So 56 will be 2 times 28, 2 times 14, and 2 times 7. So 72 we already know was 2 times, 2 times, 2 times, 3 times 3. And 56 was 2 times, 2 times, 2 times 7. Now these three 2's are common, right? And then we have to find the HCF. Right? So HCF will be equal to 2 times 2 times 2, which is equal to 8. Notice that we did not apply the rule that we studied previously, because if we quickly check just by looking at these numbers, we can say 120 is not divisible by 72 and 56 is not divisible by 72. So that is why, or 72 is not divisible by 56. That is why we do not apply that rule. We'll see in subsequent questions that how that rule can help us quickly identify HCF and LCM. Okay, so LCM is 360 and HCF is 8. The question says sum of LCM of these two numbers is 368. So sum of LCM of this and HCF of this. So this is 360 and this is 8. If you add both of them, you get 368. Now you see, don't have to solve the remaining three options here, right? Because this is the only option that has A as true. So this becomes the correct answer, right? So just to see if we are able to get the concepts, we'll be solving the remaining three as well. So the second question says there is only one common multiple of 3, 4, and 12 between 30 and 40. Okay, so see how to solve these questions. You are given three numbers, you have to find the common multiples, right? So best way is to find the LCM of these three numbers. How can we find the LCM of these three numbers? We can use the listing method, right? So what we can do is 3 is 3, 6, 9, 12, 15, and so on. 4 is 4, 8, 12, 16, 20, and so on, right? And then 12 is 12, 24, 48, and so on. Now you see 12 is common among all of these, and it's the smallest common multiple. So 12 will be the LCM. So the same logic goes for three numbers, the same logic will go for four numbers, no matter how many numbers you have. So you list down the multiples and then find the least or the smallest common multiple among them. Right, so we have 12. So 12 is the smallest common multiple. So the next common multiple will be 24. Next common multiple will be 36. Next common multiple will be 48. So these are the common multiples of all these three numbers. Okay. Now the question says there is only one common multiple of these three numbers between 30 and 40. Right. So you can see between 30 and 40 only 36 is lying, which is only one. So that is why this is true. This one was also true. Now they'll give a deliberately give a tough question and the options will be all true. Right. So if you don't look at the options, you'll be stuck in this question. The third question, again, we don't have to solve this. All factors of 48 and 50 are less than 50. Now you have all factors of 48. All factors of 48. Factors are always, factors at max can be equal to that number. It can never be greater than that number. So all factors of 48 must be either less than or equal to 48. So the highest factor of 48 will be 48 itself. And the highest factor of 50 will be 50 itself. But the question says all factors of these two numbers are less than 50. Right? But we know that for this number, we'll have 50 as a factor. So 50 is equal to 50, not less than 50. That is why this is false. Okay. The fourth question. Prime factors of 39 are 3, 13 and 39. Again, we don't have to solve this. The question says prime factors of 39. Right? And then it says 3, 13 and 39. So 3 is a prime number, 13 is a prime number and 39. Is 39 a prime number? No. Why? Because 39, if you write the factors of 39, it will be 1 and 39. So these are one factor pair and then 3 and 13. So these are 3 and 30. So these are another factor pair. So it has more than two factors. So that is why it is a composite number. So prime factors of 39 are only 3 and 30. So you can use the factor tree and then also derive this. So 3 and 30. So these are the only prime factors. So that is why this is also false. So we have true, true, and then false, false, which is E. Okay. So in this question, we are given two houses, house 1 and house 2. Now the question says, and again, there are two numbers. So in each of the houses, there are two numbers. So 24 and 42, 12 and 30. The first question, difference between LCM of both the numbers on house 1. So LCM of both the numbers on house 1 and HCF of both the numbers on house 2. So we calculate the HCF of both the numbers on house 1. We calculate the HCF of both the numbers in house 2. And then we calculate the difference between them. So we'll get something. We need to find the value. Okay. So first of all, we'll find the LCM of both the numbers on house 1. So we have 24 and 42. Again, they are greater than 20. So we'll just use factor tree and not the listing method. So 24, 2 and then 12, 2 and then 6, 2 and then 3. Right. And then 42 will be 2 and 21, 3 and 7. Right. So 24 will be 2 times 2 times 2 times 3. 42 will be 2 times 3 times 7. Right. So if we have to just list out the common numbers, so 2 and then this 3. So they are common. Right. So we are interested in the LCM. So it will be 2 times 2 times. So we have written this, we have written this, then 2 and then 3 and then 7. Right. So 2 twos are 4, 4 twos are 8, 8 threes are 24, 24 7 we can calculate. So 7 fours are 28, carries 2, 7 twos are 14, plus 2 is 16, 168. Right. And then you have both the numbers on house 2. So we have to find the HCF. So 12, it will be 2 and then 6 and then 2 and then 3. 30, it will be, let me write it here. 30, it will be 2 and then 15, 3 and then 5. Right, so 12 we can write as 2 times 2 times 3. And 30 we can write as 2 times 3 times 5. So what is common among them? 2 is common and 3 is common. Right, so here we are finding the HCF. HCF is 2 times 3, which is 6. Now we have to calculate the difference between them. So LCM was 168, HCF is 6. So the difference between them is 162. Now we can eliminate two of the options which are not 162, that is B and D. B and D cannot be correct. Right. Now between A and C, we just have to check any one of these, right? So because if you look at Q, it says 5 and it says 3. So if I am able to find the answer for this B, then we can easily say that this is correct without even solving for R. Right? So total number of prime factors of the greatest number among the number on the houses. So which is the greatest number among all the numbers? It is 42. Right? So how many prime factors does this have? So we have already calculated the factor tree. Right? So it will help us identify the prime factors. So 2, 3 and 7 are the only prime factors of 42. So this is the correct answer. Right? Because this says 5, this says 3. Okay, remember it is asking for prime factors and not factors. So if we had to find factors, it will be much different approach. We have to build the factor pairs, not factor trees. Okay, then the third option says number of common factors of numbers on house 2. Again, this information will help us. So we already tried to compute the HCF. Now it is asking number of common factors of the numbers on house 2. So first of all, 12 and 30. So it is not asking for common prime factors. So it is asking for common factors. So 12 we will have to find the factor pairs. So it will be 1 and then 12 and then 2 and then 6. So let me just write the factor pairs first, then we'll list them in ascending order. So 12 is 1 and 12 and then 2 and 6, 3 and 4, then 4 and 3. So 4 and 3 is repeated, so we'll not use that and we'll stop. So, and if you build the factor pairs of 30, it would be 1 comma 30, 2 comma 15, 3 comma 10, 5 comma 6, and then again 6 comma 5. So we'll not go further. Right. So 12 it would be 1, 2, 3, 4, 6, 12. And 30 it would be 1, 2, 3, 5, 6, 10, 15, and then 30. Now if you have to find the common factors, it will be 1, 2, 3, and 6. So there are 4 common factors. Right, so which is in option C. Okay, then we have this question, find the values of P, Q, R, and S. Again, first, before solving this question, we look at the options. P, everything is 12. R, everything is 12. So we don't have to solve this and this. We simply solve for Q and S. Right, S is very simple. We have to check the divisibility rule for 3. This question says, is 1389 divisible by 3? So we'll just add the numbers. So 3 plus 1 is 4, 4 plus 8 is 12, 12 plus 9 is 21. So 21 is divisible by 3. So that is why this number must be divisible by 3. So it is true. So we can eliminate the remaining options. So here we were able to identify this. So either one of B or D must be correct. Now we just need to solve for Q. Right? Now Q, again, it is very interesting. So LCM of 36 and 216. What did I mention previously? I mentioned that we must check if there is a possibility that this number is divisible by this number. So 216, if is it divisible by 36? So again, you just check the unit digit, right? So you just try to divide this by the unit digit. So 6, what should I multiply 6 with so that I should get 6 as the unit digit? Right, so what I'm doing is 216 divided by 36. Right, so what should I multiply 6 with so that I get 6 as the unit digit? It is 6, so I should multiply this with 6. So We'll just quickly multiply to check that we are getting 216 or not. So 6 6 are 36, carries 3, 6 3 are 18, 216. So 36 6 are 216, which means that these two numbers mean the larger number is divisible by the smaller number. And when the larger number is divisible by the smaller number, we don't have to find the HCF and LCM. We can say that the smaller number is the factor. Smaller number always factor and larger number always multiple. Right? So HCF is 36 and LCM is 216. Right? So without building the factor tree, which would have taken more time, we are able to find the HCF and LCM. So the only thing is that the number should be divisible. Right? So between these two, one says 612, the other says 216. So D must be the correct answer. Right? Although we know the answer for the remaining ones, we'll try to solve them just to check our conceptual understanding. Number of factors of 60. We build the factor pairs of 60. So 1 comma 60. It is not asking for prime factors. That is why we are going for factor pairs, right, and not factor trees. So 1 comma 60, 2 comma 15, 2 comma 30, sorry. Then 3 comma 20, 4 comma 15, 5 comma 12, 6 comma 10, 7 is not divisible, 8 it is not, 9 it is not, again 10 will come. So we'll stop that process. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 factors. This we have already seen. HCF of 36 and 120. Again, we can quickly check if this is divisible or not. So 6. What should I multiply 6 with so that I get 0? So either it should be 10 or it should be 0. So both numbers, it will not be divisible. Right, so that is why 36 is not divisible by 120. So we have to rely on the factor tree method. Right, so 36, I have to write. So it will be 2 times 18, 2 times 9, 3 times 3. Right? 120, I'll have to write 2 times 60, 2 times 30, 2 times 15, and then 3 times 5. Now, without even writing, we can see what are we just have to see what are common. So this is common among both, this is common among both, and this is common among both. Right? This 3 is not common because it has only one occurrence of 3. So 2 times 2 times 3 is the HCF. So 3 2s are 6, 6 2s are 12. Right? So which is 2. Okay, now again, these are also questions from Achiever section, but they mainly check the theoretical understanding. Okay, so read the given statements carefully and then state T for true and F for false. Again, we quickly peek into the option to see if there is any possibility that we don't have to solve any question. Right here we have 3 false and 1 true. So maybe this could have been false. Again, this is a trick that we can use when we are short of time. Right. However, when everything is false, then we don't have to solve it. Here I cannot confirm that this is this third one should be false, right? I cannot confirm it, but there is more certainty. There can be more certainty, right? But it may be possible that this is also correct. However, when everything is false, we are 100% sure that it will be false and we don't have to solve this question. Okay. The first statement says 2 is the smallest odd prime number. Right? We know that 2 is the smallest prime number, not the odd. 2 is an even number. Right? 2 is the smallest prime number, 2 is the only even prime number. Right? So this is false. So we now know C and D can be correct. The number of factors of largest 3-digit prime number is 5. Again, this question contradicts itself. So the number of factors of largest 3-digit prime number. The largest 3-digit prime number, we don't have to write that prime number. So if it is a prime number, how many factors will it have? It will have 2 factors, no matter how much digits it has. Because the definition of prime number is that if it has 2 factors, it is a prime number. That is 1 in itself. And it said it must have 5. So this is also false. Now you see this one became true. right? So there is a possibility that there is a higher probability that this may be correct. However, sometimes this may be correct as well. Okay, so we should not never make a complete guess. So that should be reserved only we have, say, 10 or 15 seconds or 20 seconds left for the exam, right? And we have to solve a lengthy question. Then the third question says the HCF of 36 and 144 is 36. Okay, now again we see that this number may be divisible by 36, so we just check for a possibility. So 6, so we'll divide 144 by 36. Again, 6 is the unit digit. We see what number should I multiply 6 with so that I end up with 4 in the unit digit. So it is 4 because 6 fours are 24. So 36 times 4. 4 6 are 24, carries 2, 4 3 are 12, plus 2 is 40. So 36, 4s are 144. So these two numbers are divisible, which means that the LCM is 144, the larger one. The LCM is 144, which is the larger one, and the HCF is 36. Right? So this is true. Now we have the final question. Read the given statements carefully and state T for true and F for false. The LCM of 15 and 20 is the same as HCF of 30 and 60. Okay, again we can quickly check 60 is divisible by 30. So HCF of 30 and 60 is 30. Now we have to see whether the LCM of 15 and 20 is same. Right. So you can either use the listing method or the prime factorization. So both will be quick. So if you use the listing method, you'll get 15, 30, 45, 60, and so on. If you list out the multiples of 20, so it will be 20, 40, 60, 80, and so on. So you can see 60 is a um, common multiple, and it's the smallest common multiple. Right, so LCM of 15 and 20 is not the same as HCF of 30 and 60. So this is false. So we eliminate C and D. Right, so these two are true. Now we just have to solve for 2 because this is true, this is false. Number 3 we don't have to solve, right, because both are true. So if we get 2 as true, then this will be correct. If we get 2 as false, then this will be correct. So the sum of all the factors of the smallest 2-digit number is 171. So what is the smallest 2-digit number? It is 10, right? Now the sum of all the factors. So what are the factors? We have to build the factor pairs. So 1 and 10, and then 2 and 5. So these are the only factors. So if we add them, we'll get 10 plus 1, which is 11. 11 plus 2 is 30. 13 plus 5 is 18. It is not 171. So this is false, which makes B as true. Right? B is the correct answer. The estimated value of 995 times 79 when each number is rounded off to the nearest tens place is 80,000. Right? So 995, if you round this off to the nearest thousand, 995, round this off to the nearest tens. So we have to round this particular number. So we log this, check whether this is greater than or equal to 5. If it is greater than or equal to 5, so what we have to do, we have to add 1 here and then make this 0. So if you add 1 to 99, you'll get 100, and then this will be 0. If this is greater than 5, make this 0 and then add 1 here, right? If it is less than 5, make this 0, don't add anything. So this becomes 1000. Similarly, 79. We have to again round this off to the nearest 10. So what we'll do, we'll log this thing, check whether this is greater than 5 or not. It is greater than 5. So we make this 0 and then add 1 to it. So this will be 80. Now if you multiply 80 with 1000, so we can just multiply 8 with 1 and add the remaining zeros. So 8 ones are 8. And then how many zeros do we have? 1, 2, 3, and 4. 1, 2, 3, and 4. So this is 80,000. So that is why this is true. Okay. Yeah. So we are going to start discussing. So this closes the discussion on HCF and LCM. And then we are going to discuss fractions in the next class.